Okay, your vocab notebook should be open to a clean page in the science section. Make sure you're in the science section, not reading or social studies. And at the top, you should have the title, Chapter 7, Lesson 2. It is called the water cycle. And then today's date, January 6th, 2021. And then we're going to start with number 1. And then put your pencil down and put your book on top. Your book should be open at page 322. We are supposed to have some independent practice today, so we need to make sure that we get to it. We're on page 322. For the mystery, girls at home, when we do the mystery science, there will usually be some materials that, or not usually, but sometimes there will be like extra materials that you'll need. They won't be anything too crazy, but I'll let your parents know, like on as soon as possible. Like I'll try to let them know on Friday what the materials needed for that lesson are, so that you can have them. A lot of this stuff is things that you'll have around the house. Sometimes it's not, but it's not going to be anything too crazy. Like maybe you need plastic cups with a lid or something. Like see-through plastic cups with a lid, but you may have that at home. Okay, but let's go ahead. You should be on page 322. This lesson is on the water cycle, and you'll see what that has to do with weather as we read. Today we're going to be talking about the water cycle. The second half of the lesson is on clouds. We will be starting that on Monday. We will be doing the cloud section on Monday. So let's get through the water cycle part today. So everybody look at this picture, and I will read the look and wonder. Be thinking about what I say as you look at the picture. Earth has had the same amount of water for billions of years. But not all of that water is in the liquid state. Some is solid ice. Some is even in the gas state. How can this be so? So anytime it rains, that's not brand new water. That water has been on Earth for billions of years. Anytime it snows, same thing. All the water in lakes has been there on this planet for billions of years. There's no new water. How is that possible? Well, it's because of the water cycle. Go ahead and turn to page 324. We're going to do one paragraph at a time. Remember, go slow. Read the whole word before you say it out loud. Don't let your brain start reading ahead of where your mouth is. Don't let your mouth get ahead of where your brain is. Mason, please loudly start with the main idea on that bookmark on the left. So pull your mask, because see how it's still touching? So that means it's muffling your voice a little bit. Okay? Everybody, finger ready to follow along. Go ahead.
Main idea.
A little louder.
Main idea. In the water cycle, water changes states as it moves between Earth's surface and atmosphere.
Okay? So it changes states. We're going to find out what that means, and we're going to draw a little diagram as we go. Okay, Mason. You can go ahead and read. Keep going.
Why does water change states?
A little louder.
Why does water change states? Water moves from Earth's surface into the atmosphere, then it moves back to the surface. Water changes state as it moves.
So we see that blue question, why does water change state? You're probably going to see it again. However, on this last outline, there was one question on the outline that wasn't in the book. But there was also one question in the book that wasn't in the outline. So what should your brain have realized when you noticed, oh wait, this question on the outline isn't in the book? But wait, this question in the book isn't on the outline, and I see all these questions come from this section. So what should your brain have realized? What should your brain have realized? It has nothing to do with this page, so I don't know why people are like, Cullen.
It was the same question, but in different words.
Very good. It was the same question, just in different words. So that means sometimes the question might not be exactly the same as the textbook, but it'll mean the same thing as one of the questions in the textbook. So where are you going to find the answer to those questions, Cullen?
In the textbook.
In that section of the textbook where the question is not exactly the same, but means the same. Remember, the older you get, the less you find the answers word for word. The more you read the answers in a different way, and you have to change them around, but they mean the same thing. Okay, thank you, Mason. Go ahead and read next. Aaron. That's a long E at the beginning.
Evaporation.
A little louder.
Evaporation. Water seems to disappear when we evaporate. Evaporation is the term for a liquid changing slowly to a gas.
Okay. So, Aaron, what's our first word?
Evaporation.
Evaporation. Make sure you're spelling it right. I have it up here and you have it in your book. And Aaron, what is evaporation?
The term for a liquid changing slowly to gas.
And instead of term, we're going to put the process, because it is a process, of, and then everything else is going to be the same from the book. The process of a liquid changing slowly to a gas. So when a liquid starts as a liquid, like water or juice or, like the wet stuff, that's liquid. Liquid changes to a gas, that's called evaporation. It's evaporating. It's changing from a liquid to a gas, which is the stuff that you can't see. It's just like floating in the air, you cannot see it. Aaron, when you're ready, continue.
Liquid water.
Louder.
Liquid water doesn't really disappear. It just changes into gas.
Good. So think about when I talked about the pot. If you've ever accidentally, like your parents have accidentally left a pot of water boiling on the stove and kind of forgotten about it, you'll come back and it'll be empty, or at least a lot less water. That water didn't disappear. It still exists. It's just not a liquid anymore. It's a gas. It's now in the air. You can't see it. It's water vapor now. And eventually, at some point, it'll change back into liquid, usually as rain. So, that's what happened. It didn't disappear. Water never disappears. If you look, and like the puddles, after it rains, you'll see puddles. And then eventually they dry up. That water didn't disappear. It evaporated. It changed into a gas. You cannot see most gases. Water vapor is a gas that you cannot see. Super quick, Michaela.
Does that mean, like, when it goes up in the air, is it going to rain in your house?
No. Usually what might happen is you might notice that there's a little bit of water. Like if you have a microwave over top or the ceiling, you might notice a little bit of water up there. That's where it went. Or usually what happens is it goes through like the cracks in your door or the window and then rains down outside. Not right immediately. It doesn't happen immediately. It takes a while. Okay, we got to move on. Aaron, go ahead and read that short little 2-sentence thing that comes next. Loud.
Water vapor is a water in gas in the gas state.
So, what's our next word?
Water vapor.
Water vapor. And what is water vapor, Aaron?
Water in the gas state.
Water in the gas state. Water in the gas state. That means you can't see it. You may be able to feel it a little bit, but not really. But water is liquid. When we think of water, that's a liquid, like in my cup right now. Victoria, will you go hold it up? Actually, no, I'll go get it. What's in here right now is water. It's liquid. Water in the liquid state is just called water. If I left this outside on a hot day, or I poured it into a pot and heated it up on the stove, it would heat up, it would start to evaporate and change into a gas. Water in the gas state is called water vapor. Okay, go ahead and finish out that little short paragraph.
You cannot see water vapor.
Little louder.
You cannot see water vapor, but it is part of the air around you.
So we can't see water vapor, but we know it's part of the air around us because of that diagram in lesson 1. It's around us right now. There's water vapor in this air. We cannot see it, we cannot feel it, but that's what gases are. We can't smell it, but think about it. Can you actually smell water when it's in the liquid form? No, it doesn't really have a smell. If there's stuff in the water, well then that'll smell, but water itself doesn't smell. We have to move on, okay? We have to. Because we have a diagram that I want to draw and I want to make sure that we have time to really talk about it. Okay, Zadie, please read next.
Water is always evaporating from oceans, steams,
Not
lakes,
steams, go slow.
streams, lakes, rivers, and ponds. The sun's heat causes particles of water at the surface to move rapidly. The more heat energy they take in, the faster and farther apart they move. Some of the particles rise into the air as a gas, water vapor.
Good. So, water vapor, evaporation happens when water does it happen when it's heated or when it's cooled? Think about what it says here. Does evaporation happen when the water gets hot or when it gets cold? Michaela? When it gets hot. Because it says the sun's heat causes particles of water on the surface to move rapidly. The more heat they take in, the faster and farther apart they move, and then some rise up into the air. And that's it becoming a gas, the water vapor. It's the same thing as when you put a pot on the stove, you're heating it up. So when liquid water is heated, it will start to evaporate and turn into water vapor. It'll turn into its gas form, which is water vapor. Okay, thank you, Zadie. Read next, Smith. Everybody ready to follow along?
Condensation.
Oh, hold on.
As part of
Sorry, go ahead.
condensation. As particles of water vapor rise into the air, they cool. The particles lose energy. They move more slowly. High in the atmosphere, the water vapor condenses to liquid water.
Condenses.
Condenses to liquid water. Condensation is when a gas changes to liquid.
So what's our next word?
Condensation.
Condensation. Make sure you spell it right. It's in your book. Condensation. We're going to put it in the same form as evaporation, so it's the process of a what, Smith?
Of a gas changing to a liquid.
Good. So condensation is the process of a gas changing slowly, because again, this doesn't happen super quick, to a liquid. So remember, the water doesn't disappear. It turns, when it heats up, it turns from a liquid to a gas. And then when it cools down, it turns from a gas to a liquid. So it's the opposite of evaporation. Evaporation, things get really hot, they turn into gas. Condensation, the gas gets really cold and turns into a liquid. So, when you're boiling that water on the stove and it starts to disappear, it rises, gets to your ceiling or the bottom of your microwave, cools off, and causes those little water droplets up there. You'll also notice this in the shower or the bathtub. Have you ever noticed when you're in the shower or the bathtub, sometimes there's drops on the ceiling, especially if you have like a tile ceiling? There's drops on the ceiling. That's because that water is hot. Some of it's real hot. There's steam when you're showering. And what's happening is that steam, that liquid, is getting hot, changing to a gas, rising up, touching the cool ceiling, especially if it's tiles, touching the cool ceiling tiles, cooling down, and changing to a liquid. You're like, but I didn't spray. I see all this water up here, but I didn't spray the ceiling. Why is there water up there? Because it evaporated, it got hot and evaporated, then it touched the cool ceiling, cooled down, and condensed. So we're going to pause right here. No, actually, sorry, I forgot. We want to keep going. Yes, quickly.
After I take a shower, sometimes I see like water on my mirror.
Yeah, and on your mirror too, because think of the surface of the mirror. Even if your house is warm, if you touch the surface of the mirror or tiles, they feel cooler than everything else. That's why when that gas, the water vapor from your hot shower or your hot bath touches those cool tiles or the cool mirror, it condenses, it cools off, and changes from a gas to a liquid. That's what's happening. So the water cycle sometimes happens just in our own houses. Yeah. Okay. Thank you, Smith. Read next. Ethan, loud and slow. Fingers ready to follow along.
Dew is
Super loud. Got it like almost like you're yelling.
Dew is a familiar kind of condensation. Dew forms when water vapor cools and condenses onto a surface. Have you ever seen drops of water cover the grass on a cool morning? Those drops are dew.
So it's the same thing. We know there's always water vapor in the air, right? Even when it's cold outside, there's water vapor in the air. Well, during the summer, what happens is during the day, the grass gets kind of warm. It's in the sun, so the sun's energy makes the grass kind of warm. Well, overnight, the sun goes down. So what happens to the grass? Does it get hotter or does it cool down? Zari.
It cools down.
It cools down, but that water vapor is still in the air. The air is still warm from the sun, but the grass has cooled down faster. Then the sun comes up, the air is still warm, but that grass is still cool. It hasn't had time to be heated up by the sun. So that water vapor that's always in the air touches the cool grass or the cool surface of your car, because it's metal. Metal gets cool. And then it changes into dew. You know dew? When the grass is wet, you're like, it didn't rain. That's why, because the water vapor in the air is touching the cool grass or your cool car, and it's condensing. It's changing back into a liquid. So it happens outside, it happens inside, it happens all over the place. Okay, thank you, Ethan. Carla, read next. Is your microphone working? Okay, Carla's not paying attention, so we're going to move on to somebody else. Carla, you need to focus. I just called your name to read, but you were not paying attention, so I'm calling on somebody else. And I'm calling on me. Everybody ready to follow along? Carla, you need to focus. This is going to be really hard if you do not focus. You've got to ignore what's going on around you. Justin, please let her do her schoolwork. Water vapor can also condense onto dust particles in the air. So there's dust on on your shelves at home and here. There's lots of dust here. Well, it had to come somewhere. Did the dust just form on your shelf? No, it's pieces of dust, microscopic dust that's always in the air, and then the particles come together to form dust that you can see. Well, this also happens like way up high in the air. There's dust everywhere. Like right now, there's dust in the air. We can't see it because it's so teeny tiny, but it's in the air. Well, it's also in the air outside. So sometimes the water vapor condenses onto those dust particles. The tiny drops or droplets form clouds. A cloud is a group of water droplets in the atmosphere. The droplets are pure water in liquid form. Sorry, I forgot. So our fourth word is the word cloud. I know it says, oh yeah, sorry. And a cloud is a group of water droplets in the air. So a cloud is formed when the water vapor condenses onto tiny dust particles. They all come together. Remember, it's condensed, so it's not a gas anymore. It's now liquid water, but it's still teeny tiny. Teeny, teeny, tiny. But they all come together, and those little water droplets and the dust create a cloud. That's what clouds are. Now, just because there's dust does not mean that you can actually stand on it. I mean, if you've been on a plane, you've probably flown right through a cloud. Did that cloud stop you at all? No. You just flew right through it like it was a bunch of tiny water droplets in the air, because that's what it was. If you've ever flown through a cloud, you might have also noticed that there was water on the side of your window, on your window in your plane. Because what are clouds made out of? Ethan? Water. So it's touching the plane, and the water is sticking to the plane a little, but the cloud is still there. There's still lots of others. Good. Okay. Read next, Michaela. Loud and slow. Read the whole word. Don't let your mouth get ahead of your brain, or your brain get ahead of your mouth.
Precipitation.
A little louder.
Precipitation. Inside a cloud, small water droplets may join together and form large ones. If it is very cold, some droplets
Not freezing, but
freeze into ice. To freeze is to change from a liquid to a solid.
okay. So what's our next word, Michaela?
Freeze.
Freeze. So number 5 is the word freeze. Make sure to spell it correctly. And we're going to put it in the same form as these other words. So it's the process of what? Of a
From a liquid to a solid.
of a liquid changing slowly to a solid. So to freeze is the process of a liquid changing slowly to a solid. So we know evaporation is when that liquid, it starts as a liquid, it heats up, it changes to a gas. Then it's a gas, but then it cools down and it changes to a liquid. Now it's a liquid, but it cools down even more and it changes to a solid. What is solid water called? We know water in the liquid state is just water. Water in the gas state is water vapor. What is water in the solid state? Smith?
Ice.
Ice. Exactly. If I took my water cup, I took my liquid water right here, and I poured it into a ice cube tray. And then I put that into the freezer. It's going to get super, super cold. It's going to freeze. It's going to change from a liquid to a solid. Now, what would happen if I put those ice cubes into a pot on the stove? What process? Ooh, this is actually a new one. What would happen first? What would it change into? Those ice cubes, that solid water that's ice, would change into what form? Mason.
Water.
Which is a liquid, gas, or solid? Liquid. Well, what if I left it on the stove? That's called, wait, hold on. Sorry. What is it called when a solid, the ice, changes into liquid, the water? Who knows what that's called? You all have heard this word and used this word and you know this word. Kingston? Melt. It's melting. When a solid turns into a liquid, it melts. A solid cannot go straight from a solid to a gas. It can't happen. So, I took my cup of water. It's in the liquid state. I poured it into an ice cube tray, put it in the freezer. It started to freeze. It changed from a liquid to a solid, ice. I put that solid ice into a pot and put it on the stove. Mason told us that it melted and changed from a solid back to a liquid. What would happen if I kept it on the stove? What process would happen? Michaela?
It would go to water vapor.
Well, it would, what's the process called? When it heats up and it changes state from liquid to, let's see, Zadie, can you help her out?
The process of evaporation.
It would evaporate. It would change from that liquid water to a gas called water vapor. And then it raises to the cool ceiling. That water vapor hits the ceiling, and what process happens when it starts to cool down? It does what? That water vapor, that gas, hits the ceiling, it cools down a little. What process happens? Smith?
Condensation.
It condenses. It turns back into a liquid, and then say I collected it, I wouldn't have much because most of the water vapor is going to escape through like cracks in the windows and the doors and everything, or to other rooms. I could do the whole process all over again. Does it ever stop? No, it never ever stops. That's why it's called the water cycle. A cycle never ends. It goes on and on and on and on and on and on forever and ever and ever until somebody physically stops it. But nobody can stop the water cycle. Okay. Go ahead and read that last little bit, and then we are going to draw a diagram of these solids, of these the changes to the states of matter. Zari, are you able to read?
Yes.
Okay. Go ahead. Read that last paragraph loud and slow. Everybody follow along with your finger. Zari, make sure that your brain and your mouth are staying at the same speed. Carla, please put those away and follow along. Go ahead.
The droplets and bits of ice grow larger and heavier. When they are too heavy, they fall to Earth's surface. Precipitation is the term of water that falls from clouds down to earth.
Good. So what's our next word, Zari?
Precipitation.
Precipitation. And what is precipitation, Zari?
The term for water that falls from clouds down to earth.
Water that falls from clouds down to earth. Remember, earth is the specific name of the planet, so it is capitalized. So precipitation is water that falls from the clouds down to earth. Now it says from the clouds. So if you are in your shower and you notice that water droplets on the ceiling and they fall, is that precipitation? Why is that not precipitation? Aaron?
Because precipitation is water coming from clouds.
Because precipitation comes from clouds, not the tile ceiling of your bathroom. That's just water falling from the ceiling of your bathroom. That's the term for that. There may be a scientific term, but I don't know what it is. Okay, we're not going to have time to do the diagram, but that's okay, because I do want to look at this picture down at the bottom. So everybody look at the picture on the bottom of page 324. This is a diagram of what we have been talking about. Step 1, what happens? Victoria,
What happens first is
loud so we can all hear.
the sun's energy heats the surface of the water.
So the sun shines on this little pond, and the surface starts to heat. Then what happens, Kingston?
Particles of water evaporate from the surface. They rise into the air as water vapor.
So particles of the water on the surface got hot, they got warmer, and they evaporated. They changed from liquid to a gas and rose into the air as water vapor. Then what happens, Colin?
As they rise higher, the particles of water evaporate, cool, and condense.
Not water evaporate.
Water
Vapor.
vapor.
One of our words. We've been saying it. You've got to remember because we've been saying it a lot, okay?
Water vapor cools and consists.
Not consist. That's not an S.
Oh.
Read that sentence again, please. What happens third?
As they rise higher, the particles of water vapor called
No.
cool and
We read it. It's part of it's the base word for one of our vocab words. Can somebody help her out? Mason. Condense.
condense.
Okay. So then the water on the surface of the lake has heated up. It's rising in the air as water vapor. What happens the higher we go in our troposphere? It gets hotter or colder? Victoria.
It gets
Not hot. Think of if you go up a mountain.
it gets colder.
It gets colder. So that water vapor rises in the air, it gets cold, it gets cool, it condenses. It changes from water vapor, that gas, back into a liquid, that liquid water. Now it's liquid water up in the cloud. What happens next? Zari.
When droplets
Oh,
in the
nope, you skipped one.
clouds-
You skipped one. That's 5. We just finished 3. 5 doesn't come after 3.
Clouds form from droplets of liquid water.
So, that water has condensed. It's cooled down. That water vapor has condensed and cooled down back into a liquid. Now we get a bunch of those water droplets and they form a cloud. What happens last? Mason.
When droplets in the clouds grow large and heavy, they fall to earth.
So lots and more water droplets come together until they are too heavy and they fall back down to earth. Is that the end? Is the water done forever? Does it just stay? No. What happens next? We don't have a step 6, but what is step 6? Zadie.
It happens all over.
It starts all over again. So number 6 is also number 1. After number 5, it goes back to number 1, and the same thing happens over and over and over and over and over and over and over again until the world explodes. And it is done. Or whatever happens at the end of the world. That's when the water cycle will stop. So step 1 is also step 480,000. Because it'll start over and over and over again. Okay, let's go to the next page. We have like 20 minutes. We need to finish this page and talk about this diagram. We can do it if we focus, if you guys don't get me off topic, and if you answer the questions and are ready to answer the questions I ask. Please make sure that you're paying attention so that you're ready. Also read slowly. Don't let your brains get ahead of your mouths or your mouths get ahead of your brains so that we don't have to stop and read again. Victoria, please read next. Loud and slow. Quickly, please.
Where does water go? By now, you know a lot about water. You know that water can be found in many places. You know it has 3 different states.
What are the 3 different states of water? Tell me the names, the specific names of water and what state they're in. Zari, tell me one.
Evaporation.
That's a process. That's not a state. That's not a state of the water. Mason?
Water vapor?
Water vapor, which is water in what state? Gas, liquid, solid.
Gas.
Gas. Remember, the states, when they're talking about the states, they're saying gas, liquid, or solid. So Mason told us water vapor is water in the gas state. What's another one? Michaela?
Precipitation.
Nope. That is not a state. Zari?
Cloud.
Nope. Guys, remember I said the states are liquid, gas, solid. Clouds is not the name of water in any state. Precipitation is not the name of water in any state. Kingston?
Water and ice.
Ice. Ice is in what state? Is water in which state? Solid. And what's the last one? Zadie?
Water.
Water. Which is water in what state?
The liquid.
The liquid state. So we know water, vapor, is water in the gas state. Ice is water in the solid state. Water is water in the liquid state. We can find it in many places. We can find it in our bathrooms. We can find it in our kitchens. We can find it in our classroom. We can find it outside. We can find it in the parking lot after the rain. We can find it on the playground after the rain. We can find it in lakes, in rivers, all over the place. You probably have it in your rooms where you are at home. We can find it all over the place. Well, it came from somewhere and it's going somewhere. Cullen, please read next. Loud and slow.
Water is always moving from place to place, in one form or another. The water cycle is the earth.
Nope.
Is the movement of water between Earth's surface and the air.
So, what's number 7?
Water
Colin?
cycle.
The water cycle. And what is the water cycle, Cullen?
Is the movement of water between Earth's surface and the air.
The movement of water, not between air surface, but between
Between Earth's surface
and
the air.
between Earth's. So the water cycle is the movement of water between Earth's surface and the air. Make sure that you have capitalized Earth because it is the specific name of the planet. It also has apostrophe S because what does the Earth have? It's a possessive noun here. What does it have or own? Colin?
Surface.
A surface. So it needs an apostrophe. Do plural nouns need apostrophes? Class. Do plural nouns need apostrophes? Class.
No.
No. Only possessive nouns. Now sometimes nouns are possessive and plural, but they only have the apostrophe because they're possessive, not because they're plural. It just changes where you put it. Okay, Cullen, when you're done, go ahead and keep reading. So the water cycle is just how that water moves between Earth's surface and the air.
Evaporation,
Chunk it. Don't just stare at the word and expect it to come to you. Chunk it. So take each syllable, read each syllable separately, then put them together into a new word. And remember those phonics rules, like what does TION always say at the end of the sentence? Look.
Condensation and precipitation help water move through the cycle. The diagram shows you how.
So, evaporation, condensation, and precipitation are all parts of the water cycle. Evaporation is when it, we already know evaporation is when it heats up on the surface and rises into the air as water vapor. We know condensation is when it cools down and becomes tiny little water droplets in liquid form in the air. We know precipitation is when it gets heavy and it falls back to Earth, still as a liquid. Well, now let's look at how and when each of these things happens outside. We talked a lot about how it happens inside our houses with water in a cup. Now let's talk about how this happens outside, in the air. Kingston, please read next, loud and slow. And then we'll look at the diagram after. We'll read about it and then we'll look at the diagram. Go ahead.
In the air. In the water cycle, water changes state between liquid, gas, and solid. The sun is the energy source for this cycle.
The sun provides the heat. Without heat, would water ever be able to change state? No, because it wouldn't be able to evaporate. It wouldn't be able to cool down. It wouldn't be able to get freezing cold. It wouldn't be able to heat back up again. So we need the sun's energy, which causes the heat, to keep this whole thing going. If we did not have the sun's energy, it would be ice all the time. And then, can we do anything with ice other than keep drinks cool? No. Okay, keep going.
The sun's energy causes water to evaporate from lakes, oceans, and other bodies of water. Water also evaporates from the leaves of plants. This is called transpiration.
We learned about this. We learned about how when the water leaves the plant's leaves, in our chapter about plants, we learned that was called transpiration. The process of the water leaving the plant's leaves. Okay, keep going.
As it rises, the air.
You left out a word. As it rises.
As it rises in the air, the
Louder.
water.
Louder. You're doing really well, so don't keep it up.
As it rises in the air, the water vapor
Not condensation, just, it's okay. Don't forget.
condenses.
Good.
Clouds form. During precipitation, water falls from the clouds over land and water.
Okay. Carla, you're being extremely distracting right now. You need to stop playing with that and you need to focus. Okay, so we can see on this page, if we look down at the diagram at the bottom, we see this large body of water. Maybe the ocean, maybe a bay, maybe a massive lake, whatever. It's a large body of water. We see the sun above it. Do you see the sun? Do you see the large body of water? The sun heats the surface of the water, and what process happens? What process happens when the sun heats the surface of the water? Zadie?
Evaporation.
Evaporation. So we follow that arrow and we see evaporation happening. Why have they not drawn the water vapor in the air so that we could see it? Michaela? Because we can't see it. It's microscopic. We cannot see it. We can't feel it most days unless it's superhuman. Good. Then we follow that arrow and the water gets cool. And what happens? What process happens when that water vapor cools down? Smith?
Condensation.
Condensation. It changes back into water. It comes together with little pieces of dust and other teeny tiny little droplets of water and becomes a what? It all comes together. The dust, the tiny droplets of water, and they become a, Victoria? Cloud. Then the tiny droplets of water inside the cloud join together and they get too heavy, and what process happens? Zari?
Precipitation.
Precipitation, which we see over on the top of the diagram on page 327. We see the cloud. Well, notice the difference between the cloud and condensation and the clouds where precipitation is. The cloud and condensation is very small and white and fluffy because there's not all that much water yet. But then you get to the precipitation clouds and they are much bigger, they are darker, and they're not quite as fluffy. That's because think about if you have juice and you have a little bit of juice at the bottom of a cup. You can see through it pretty easily, right? Because there's not a whole lot. Like if it's a clear cup and you put it over a piece of paper, you can see through it. But the more juice you put in there, the darker it gets, the harder it is to read. It's the same thing with clouds. The more water that is in there, the darker they get, the bigger they get, and then they get too heavy. Those little droplets get too heavy and they come down to the earth as precipitation. Well, now we have all these other little words. Some of them we know, like evaporation, because we have this little mountain lake. And the same thing happens. The sun heats it, it evaporates. We know transpiration. We can see transpiration is coming from the trees because what is transpiration? Why is transpiration coming from the trees and it has an arrow pointing up? Why is there an arrow next to transpiration coming from the trees? I don't know why people are moving back. We literally just talked about this like 3 seconds ago. You're just trying to make it look like you're looking for the answer, but you're not really. You're waiting for somebody else to answer. Victoria.
Because it evaporates from the leaves on the trees
Good.
up to the sky.
Good. There is an arrow coming from the trees next to transpiration because transpiration is when water evaporates from the leaves of plants. Trees are a plant, so that's why the arrow is coming from there. Evaporation is when it comes from a body of water, whether that is as small as a puddle or as large as the ocean. Transpiration is when it evaporates from the leaves of plants. Everybody needs to be paying attention. Some of you are zoning out. Well, good luck on your science grade. That's all I can say. But now we have these other words, runoff and groundwater. What are those? Well, please tell us, Carla.
On and below.
Justin, Carla is reading. Please leave her alone.
On and below the ground.
Precipitation.
Precipitation can fall as rain, snow, silt, or
Not silt. Silt. Read those letters in order.
Precipitation
Precipitation.
can fall as rain, snow, sleet,
Sleet. Read the letters in order. It's S-L-E-E-T. S and L together make the sl sound. E-E together say E, and T says T. So sl-e-t. Sleet.
sleet, or hail. When it rains, water flows over Earth's surface as a runoff. Runoff gathers in the lake, ocean, rivers, and streams. Over time, water collects in glaciers, glaciers, and ice caps.
Good. So now we know what runoff is. Find runoff on the diagram. You can see it's next to that little stream going down the mountain. That's because runoff is rain that lands on the earth and then flows over its surface. So also, you know when you see water in the curbs next to like the sidewalk, that's also runoff. Because it's raining into those curbs. There's a lot of water and it's running off down into the sewer. Well, it also happens on the sides of mountains. Because it has to go down, gravity pulls it down, so it flows down the side of a mountain or down the curb in a street. Please make sure you're paying attention. And it ends up back in rivers, lakes, or oceans. Because think about where the sewers go. Especially if you're downtown, you see those little things with like fish on it. There's like a little logo that has a picture of a fish and it says, "Don't dump, this leads to the river," or something. That's because most water that enters those sewers goes back into a river or a lake or an ocean. In our case, the Mississippi River mostly. And then what happens to it once it's back in the Mississippi River? What happens to it next? Zari.
It goes back through the water cycle.
It goes back through the water cycle. It evaporates again. Well, runoff is not the only way that water gets back to the ocean, or the runoff is not the only place where water goes when it rains. Please read next, Mason, loud and slow.
Rainwater also soaks into the ground. Plants take up some of the water from soil. The rest collects in the small cracks and spaces below the ground. This groundwater can stay above the bedrock, flow, or slowly.
That's one of our vocab words. That's a long E. The rest of it is spelled exactly how it looks. Chunk it. Here, I'll help you. I'll show you what I mean by chunking it. Short A. Not evaporation, because then we end with, how would you say that? So E, back. So loud. Read that sentence again. Loud, loud, loud.
This groundwater can stay above the bedrock, flow, or slowly evaporate.
Very good. So not only does water end up as runoff, but sometimes it just stays on the ground, because think of like flat dirt. Is there really anywhere for it to go? Like on our playground, does it go anywhere, or does it just stay there until eventually it absorbs into the ground? That's groundwater. And what happens is it keeps going down, 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 down into the rock that's below the surface, and it stays there. Or it may run through cracks back into a river or ocean or stream or lake. Or it can sometimes evaporate even in there. If it's really hot, it might get hotter down under there. If the ground is hot enough, it might evaporate from under there. So there's lots of places where the water goes. Does the water ever disappear? No, it just changes state. So when your water is in your pot and you leave it on the stove too long, what has that water turned into? It's not liquid water anymore. What is it now? Carla?
Water vapor.
Water vapor. And then water vapor eventually cools down and turns into what? Water vapor cools down and turns into what? Mason?
Condensation.
Well, it condenses. That's the process, but it turns into what? Water in the water vapor cools down. It condenses back into Smith.
Liquid.
Liquid, which is called, what is water in the liquid form called? Smith. Guys, water in the liquid form is called what, class?
Water.
Water. Remember that. Water in the liquid form is water. Water in the solid form is ice. Water in the gas form is water vapor. Okay, we didn't have time to do the independent practice, but we'll have that as morning work tomorrow. So girls at home, the independent practice, you'll do it tomorrow morning when you log on at 7:30. I'm sorry. At
9.
no, what time? Yeah, 7. Wait. What time do they get on? Why can't I remember? What time do you guys get on in the morning?
8:30. 8:30.
Oh, tomorrow's math though.
9:30.
Okay, yeah, tomorrow's math, I forgot. So, just in the morning at some point, I would like you to do, like while you're waiting for math to start, I would like you to do that morning work. Because that's what the
Is it
kids in
basically
school.
like yesterday's, the 3 problems?
Yes, it's just a diagram sheet. So, you guys stay on after dismissal and I'll explain it to you. Since I'll be able to explain it to them tomorrow morning, but I won't be able to explain it to you. So just stay on for like a minute or two after dismissal and I'll explain it to you. Okay?
I'm able to stay on as long as you want me to.
Yes.
Yeah, I'll do
Okay.
something, but I won't be able to do it because I will have speech therapy.
Well, I'll tell you about it this afternoon. Okay, right now I'm passing out your homework. It is vocab. It is optional. It is extra credit. It is not due till Monday because we don't have science again until Monday. So put this in return to school. It's just the vocabulary. You know how this book has vocabulary for each chapter? For each lesson, and it has an outline for each chapter. This is just the vocabulary. So you may have to read ahead, but you will only have to skim ahead. For vocabulary, you mostly only have to skim ahead of where we are. It is optional. It is due on Monday or before. You do not have to do it. Remember the front. You guys, I don't know why you have such a problem with this. The front is the smaller page number. Page 148 is smaller than page 149. So which one is the front? Cullen?
149. 148.
148. So where does your name, number, and date go? On page 148 or 149, Cullen?
148.
148. Please put that in return to school, and then you can just leave your return to school folder out, and you can also go ahead and get out your planner. Please put everything else away. I know you're probably just going to get it right back out, but it will be easier to make sure you have everything.